Hello, how are you guys? So today we would continue um, on examining the behaviors of gases. So if you guys watch my previous video, I've talked about Boyle's law, Charles' law. So today I'm going to be touching about Gay-Lussac's law. So Gay-Lussac is one of the scientists that studied the behaviors of gases. Like we know, so matter is made up of three entities. So number one is solid, the second is liquid, and the third is gas. So, and all these three entities, they behave, in a very different and unique way according to how much matter they have contained in them. So in solid, the matter is really packed. So that is why solid don't move randomly, because it's tightly packed. So there is not enough space for solid to move. So in liquid has a wiggle room because the matter inside the liquid is not heavily packed. So that is why a liquid can take the shape of whatever container it's put in. Then the third one is gas. So gas, the matter in gas is loosely packed. So that is why gas could move at random. That is why if somebody, like say you spray a perfume. So that is why if you spray a perfume in a certain place, if you go to another place that is not very far from where you spray the perfume, you could actually smell the perfume. So that means the gas is traveling at random. So those are the three major difference between gas, liquid, and solid. Now, so in many years, so scientists have actually studied the behaviors of gases. They want to know what is characteristics, what makes gas behave in a certain way. So, and they've now, they now come up with several things. So number one is pressure, another is temperature, and another is volume. So they study all these entities to be able to pinpoint, if gas is subjected to all these entities, how will the gas behave? So today is going to be the turn of Gay-Lussac, and Gay-Lussac law states that if you increase the pressure on a gas, the temperature is also going to increase, and vice versa. If you increase the temperature on a gas, so that means the pressure is also going to increase. So what does that tell us? That tells us that pressure and temperature, they have what? A direct relationship. So that means if pressure goes one way, temperature is going to go the same way. And if temperature goes the same way, then pressure is also going to go the same way. And in our science, so we represent our direct relationship by, so let's say this is our pressure, then our direct relationship is always represented by something that looks like a fish. Then temperature. So anytime you see this kind of symbol, so you automatically know that this is a direct relationship that we're talking about. So, but if you see this, pressure 1 over volume. So whenever you see this kind of relationship, you know that without even anybody saying anything, you know that this is talking about what? An inverse relationship, opposite. That's why it's called inverse. Now, so Gay-Lussac's law, so we could actually use Gay-Lussac's law and the formula to be able to calculate, if we are given a certain part of the problem, we could actually use it to find another part of the problem. So let's say we are given pressure, temperature, and then we increase the pressure and temperature as well. So they may ask us, okay, so what's going to be the temperature or the pressure of the other thing that they increase? So a very good example is, so let's make up a problem. So remember that Gay-Lussac's law says that when pressure goes up, what's going to happen to the temperature? The temperature will also go up. So we say that they have what? Pressure and temperature. They have a direct relationship. So they always move in the same direction. So let me make up a problem, then we'll solve the problem, and you guys will see how easy it is to use this law. So the law states that P1 over T1 is equals to P2 over T2. So P represents pressure, temperature represent, T represents temperature. So pressure 1, temperature 1, pressure 2, temperature 2. So let's say we have a balloon. So let's say the balloon has a pressure inside it. So let's say 2 Pascal, because that's how we measure pressure. We measure it by Pascal. So a balloon with 2 pressure was inflated with a temperature. So, and remember in Kelvin, the temperature, we measure it in Kelvin. So let's say, just for example, so let's say 100 Kelvin. So the balloon has 2 Pascal, 2 pressure in it, and it was inflated by 100 Kelvin. So let's say we now increase the pressure to, let's say, 4 Pascal. So we increase the pressure from 2 to 4. Now, so they now ask us what is going to be the temperature of the new balloon. So what is the temperature? So our 2 PA, 2 Pascal is going to be our P1. Are you following me? Then your 100K is going to be your what? T1. Then your 4 PA, your 4 Pascal is going to be your pressure 2. Then the new temperature we are asked to find is going to be my what? T2. So we have everything that we need to calculate this. So we have our P1, T1, P2, then we are asked to find our T2. So using this formula, so I'll show you guys how easy to manipulate this. So we say P1 divided by T1 is what? P2 over T2. So we ask to find T2. So how do you do this? So this is an easy method. So all you need to do is cross multiply. So when you cross multiply this, so it's going to give you what? P1 T2. Remember, we're cross multiplying it. Then it's going to be what? Equals what? P2 what? T1. So are you guys seeing this? Now, so we're asked to find what? T2. So what do we need to do? Simply all you need to do is, where is our T2? So our P1 T2 is on the left. Then our P2 T1 is what? On the right. So all you need to do is, we need to isolate our T2. And how do we do that? You just bring your P1 to the right hand side. So it's going to be what? P1. So now let us clean it up. So T2 is what? P2 T1 over what? P1. So do you guys see that? So I started by cross multiplying. Then I want to isolate my T2. So I said, all I need to do is bring my P1 here, down here. So it's going to give me what? T2 is what? Equals P2 T1 divided by P1. So that is how easy it is to isolate your problem. Now, so since we have our T2 here, so what do we need to do? You need to go back to your question and start plugging in your figures. So where is my P2? My P2 is what? 4. Where is my T1? My T1 is what? 100. And where is my P1? My P1 is what? Divided by what? 2. So let us now cancel. So 2 goes here, 1. 2 goes here, 2. So 2 times 100 is what? 200. Don't forget, temperature is what? In Kelvin. So do you guys now see that it makes sense, right? So my new temperature is going to be what? 200 K. And remember I said the relationship between pressure and temperature in Gay-Lussac law is direct. So see, we increased the pressure from 2 to 4. So what's going to happen to the temperature? The temperature will definitely increase from 100 to 200. So you could see that temperature increased, pressure also increased. So you could see that this is a direct relationship. They both increased, in the same direction. So that is Gay-Lussac law. So to round up, Gay-Lussac law say that if you increase the pressure, the temperature is going to increase. And if you increase the temperature, the pressure must also increase. Because why? They have a direct relationship. So that is Gay-Lussac law. So once again, this is Mr. B's Chemistry, and we've studied Gay-Lussac law today. So if you guys are still watching this presentation, so that means you guys are, probably getting something from it. So I want you guys to write down, in the comment below to tell me, what other chemistry things do you guys want to see, and to just let me know, give me a feedback on how you guys are getting from this. And of course, this is going to be, the time to subscribe, like, and turn the notification bell on. Because when you guys subscribe, it lets me that I'm doing the right thing, giving you guys free content, and somebody is actually getting from it. Because when you subscribe, it pushes this video to other students so that they'll be able to gain something from it. So once again, thank you. This is Mr. B's Chemistry. I'll see you guys next time. Bye.